Write down the balanced chemical equation and given quantities. The balanced equation for the reaction is C3H8 plus 4Cl2 gives C3H4Cl, 4 plus 4HCl. The starting quantities placed in the reaction vessel are 6.0 moles of C3H8 and 20 moles of Cl2. Understand the concept of the limiting reactant. When reactants are mixed in non-stoichiometric ratios, one reactant will run out first. This substance is the limiting reactant, and it dictates the maximum amount of product that can physically be produced before the reaction stops. Determine the limiting reactant mathematically. Calculate how many moles of Cl2 are required to completely react with all 6.0 moles of C3H8. Moles of Cl2 required equals 6.0 moles C3H8 times 4 moles Cl2 over 1 moles C3H8 is equal to 24 moles Cl2. Compare this required amount to the actual available amount of Cl2, 20 moles. Because the required amount, 24 moles, is greater than what is available, 20 moles, we do not have enough chlorine to react with all of the propane. Therefore, Cl2 is the limiting reactant and will be totally consumed. Propane, C3H8, is in excess. Calculate the theoretical yield of HCl. Using the initial moles of the limiting reactant, Cl2, and the stoichiometric mole ratio from the balanced equation, for moles of HCl produced for every 4 moles of Cl2, consumed moles of HCl produced equals 20 moles Cl2 times 4 moles HCl over 4 moles Cl2 is equal to 20 moles HCl. This matches option C. The correct answer is option C, 20 moles.